We're going to do a video today on how we take a 3-view off the internet and turn it into using CAD, turn it into a fuselage for a Fokker D8.
So the CAD software we use is a thing called Rhino 3D. There are lots of different CAD programs you can get, Fusion 360s and AutoCADs and all sorts of things. We like Rhino, we've used it for years and years and just very comfortable with it, and it allows us to draw organic-y shapes very easily. It's not all regimented and dimensioned like some CAD programs. It's organic, which is what fuselage curves are. You can download a version, a full version of Rhino 3D for free, and it's free forever. For the first 90 days it allows you to save and save your work. After 90 days it stops saving, but you can go on using it. So you can't really beat the price for free, and if you do want to buy it, it's affordable to get after that.
In 90 days while we're all at home, there's a good chance to learn something.
So
We'll
start with a what we're all used to is 3 views. You just go on, you can Google, like this is the dock of Fokker D8. So you can go on and Google a 3 view for a Fokker D8, and there are squillions of them. And we're all familiar with, you know, right clicking and saving, save the image. You can come into Rhino. Rhino, when you start Rhino, it comes up with this, the 4 screens: a top view, a front view, a right view, and a perspective view. You can click on one of those views to make it your main view, and you bring in the 3 view you just saved. So you go point to 3 view, double click it, and draw it. And there's your 3 view that we've just got off the internet. We're all familiar basically with this: front on view, top view, side view, and some cross sections. Rhino works in true dimensions, so we can measure, you can measure things like distance. This thing is 2.2 meters across. We want the wing to be 2.2 meters, so you can scale it. So it's got menus, lots of buttons. You don't have to know what all these buttons do. There are hundreds of them. You need to know probably a dozen of them, things that do what you want to do. So for us here, we've just brought in a picture. It could be whatever size. We want to dimension it, so you can scale it, 2D scale it. So by right clicking, we can say that the wingspan from there, turn on ortho so it's all square, to there is going to be 2,200 millimeters. So now that whole picture is scaled to 2.2 meters. You can go in and check it, measure down there, 2.2. Once you've got that picture in there and scaled to the size you're working with, you can take the cross sections. You can trace the cross sections.
What do you mean by trace? When you tell someone to trace it, they obviously can't get a pencil out, so how do they trace it?
So what we've brought in there is a raster picture. It's not lines. All it is just a whole bunch of little pixels. So if you zoom in on this, the pixels just get bigger and blurrier. In CAD, we work with vectors. Vectors are just endpoints that are joined by a line, so they're scalable. So when I draw a line here, this vectored line, this red line, if I zoom right in on that red line, it doesn't break up. It stays fine. And if I come right out, it stays fine. Whereas the raster image, the image we've taken off the internet, is a raster image, and it just breaks up. So you just zoom in and it just blurs out. Whereas a vector line, which is what CAD uses, when we zoom in on this, it doesn't break up.
That's your red line.
Yeah. So zoom back out and it stays one line thick. So Rhino has a tool, a drawing tool, all sorts of drawing tools, as you can imagine. There are heaps of them. So the one we're going to use is this thing, which is, it draws a curve through points. So we come down to our raster image, sit on there, and we just click points around the shape. And it puts up, don't click the button by mistake. You click,
Just follow the outline.
line. I'm just doing it roughly here, but this is basically the idea. We don't want to be on perp. Anyway, you do this a lot neater if you're doing it properly. I'm just roughly doing it. So you can see roughly how you can draw a shape. So that the 3-view gives us these cross sections. So we trace those shapes. This is 2D. This is like on a bit of paper. In 3D CAD, funnily enough, it becomes 3D. So we're up in here and we're looking at the top view of our world. If we come down here and click perspective, we're now in 3D world. So that thing that we just traced is there. We can take that thing out of there, bring it over here,
Drag it across,
and in Rhino this thing's called a gumball. It allows you to manipulate things in 3D space. So we can take that, which is in 2D, and we can just flip it over that way, and then we can flip it over, we can flip it to stand it up. So we've taken that 2D shape and put it in 3D space. So you can see how you can take that shape, and that shape, and that shape, and the tail shape, and assemble them about a datum line, which is what I've done here. So there are the 4 shapes taken from the 3-view, assembled in 3D space around a datum line. Make sense?
Yep, it's all looking good.
The magic bit of this, there are obviously tricks and neater ways to, and refinements to do, but in essence, what you can do is select that curve, that curve, that curve, and that curve, and Rhino will loft them together.
That's magic.
Create a fuselage. You can make it pretty, go up and put a texture on it so you can see it a bit better maybe. It's chunky because we haven't put stringers in and like refine the shape a bit, but in essence the shape is there. We go from this circle to a little bit less circle to a square to the tail shape, and you can tip it all around and look underneath it and examine the shape. And what I've done over here, this is the one I'm working from, I've just tidied that shape up, taken the sharp edges out by putting more stringers in. The more curves you put in there, the more you define the 3D shape, the smoother it becomes. But you don't want to put so many in there that it becomes too lumpy. So it's a little bit of mucking about to get a nice fair shape. But that's how we've ended up with this thing here. And the same with the wing. The wing is just this curve. Get rid of that. The wing is we've got a root shape there and a tip shape there, and lofted them together to get the wing. And that's how the wing was done. So there's not a lot of drawing in the wing. You just put in the root and you put in the tip and you loft them together. So with, you know, half a dozen curves, and a little bit of positioning in space around datum lines, you've got the basics of the whole plane there already.
Okay, so you go from that. How do you get it out of the computer into something?
We add construction bits. So we put a tube up the middle. We put up a 38mm by 16 RHS up the middle. So we draw that in. That's, I'll show you how you draw those. So there's that shape. That's going to be the tube that this whole thing is built around. You measure it, you make sure that it's 38mm by 16 and it's centered on the datum line as well. So you can just select that shape, and again, using our gumball, we can just drag it. Now there's our tube right up the middle. The next really clever thing that Rhino does, you can section this. So you've got a shape there, you've got your skin and you've got this thing up the middle. You can highlight it, say I want to section this. There's a button called section. And I can say, you know, pick a point through there. If I slice that, what's it look like? And there's the shape. You can swivel it about, bring it back into top view, and there's your cross section. So this 3D construction, you can slice up into 2D cross sections. If you were making this conventionally, like in a balsa and plywood, you know, there's your former. Just as we put this RHS up the middle, you could put stringers in, and when you slice it, it slices them, and you'd cut them out of plywood and away you'd go. We're making a plug to make a fiberglass mould of this. So we're slicing it up like a loaf of bread basically, which is what I've done over here. We've got our fuselage. Each one of these slices is 50mm apart. So we start off with a slice of 3mm MDF and then 2 bits of foam. Another bit of 3mm MDF, 2 bits of foam. So right the way down the fuselage, I've chopped it all up into MDF, foam, foam, MDF, foam, foam. And then just like we just did, you can pull out shapes. So I pulled out former 1, 2, 3 down here. So these are the MDF shapes. The foam shapes, because this thing tapers so much, like most fuselages, they look sort of square there, but if you highlight one of these and then go look at it in 3 view, it's got taper to it. So you could just slice it up, stick a bit of foam in, it's like a foam blank in there, and you know, sand the foam to shape. But I hate sanding foam. So we take this and get the machine to cut it to this taper. We get the router to cut it to this shape. Does that make sense? Mm-hmm. So each one of these slices I've taken over.
You're not having to hand shape it.
No, there's no hand, well, very minimal hand shaping. So each one of these slices, the MDF ones have come down the bottom here, They're the MDF shapes, and then the foam shapes are taken up the top. So we extract each one of these foam shapes, like all numbered, and we export them. Means take them out of this program into another program, and that's just, you know, highlight the thing.
You've got two highlighted there.
Highlight the thing, file, export, wherever we are. Yeah. Foam, fuselage foam sections, so, you know, 3A comes out of here, and we save it. We then go into another version, older version of Rhino. So we go into Rhino 5 this is an old version, I'll tell you why soon. You load in what we just saved. We just exported this section 3A. And there it is, just like we've taken out. It's got a surface on the top side. So we can highlight it, spin it. The reason we use Rhino 5 to do this sort of stuff is we have what they call a plugin. It's an extra program which works within Rhino. It comes from Italy, bought it years ago. It's not that expensive, but it creates a toolpath, and we can create a 5D toolpath. We use 3D, but it create a 5D, 5-axis toolpath path for a 5-axis cutter. And it sits here as this little sub-menu, if you like. So it's a thing called MadCam, and it's how we create toolpaths, 3D toolpaths. So tell MadCam that that's what we're working with. This is just a little bit of housekeeping. Move it down to the origin, which is down here. Wireframe's easier to see. So we go back into MadCam, we say this is the part that we want to cut. Click select surfaces, so we've told MadCam this is where we are, and you just work down the menu, the MadCam menu. Next thing is what cutter are we going to use? We're going to use a ball end 8mm, it's an 8mm ball end cutter. We wanted to cut the sides, so this extremity we want to blow out a little bit, so you can add the width of the cutter to the boundary, if you like. So it's moved the boundary out so the cutter can get down the side here. MadCam can do an awful lot of stuff, but for this we don't need it. We just need a very simple, it's called Z level finishing, which is just stepping down. It could, the 8mm cutter is quite big. You could do this in 1 or 2 passes, but we want a fine taper, so we only step down in 3mm step downs. Not much more else in that. It concerns us here. Click that, and it creates a toolpath. And it creates a toolpath in Rhino as a new layer, which it's doing now. We don't have to cut the top of the foam. It's a 50mm bit of foam, so we don't have to worry about the depth. All it's doing is cutting the sides and the holes in the middle. So we've got the hole for the RHS, and we've got 2 dowel holes just to keep the thing all lined up and neat and square. There you are. So the blue line is the toolpath, 3mm step down. So it's quite fine because we don't want to be sanding foam. We want the machine to do the foam cutting for us and to get this taper, but also the alignment holes, so everything fits together perfectly. So once MadCam has created this toolpath for us, we post-process, it's called. It takes this toolpath and turns it into G-code. We stick that onto a USB stick, so we post-process. It's for Mark III, it's metric. Post-process it. We tell it where the stick is. The stick is over here. Fuselage, it's 3A. Foam section 3A. And it's created a toolpath stuck onto the USB stick. We can go look at that toolpath. Go down to the USB stick, fuselage, 3A text files it's created, and here's the tool. This is G-code. This is what tells the motors on the router what to do, X, Y and Z. So that MadCam has just created all this G-code, which is telling the motors where to go. In with the USB stick, straight into Mark III.
Onto the other computer.
Yep, this computer's hooked up to the router, so that one does the drawing.
The drawing computer on that side.
And this one runs the machines.
And the machines, we've got the mill.
So you just load in that G-code that we just created, come across to the router. Come around this side. We've got our bit of foam there. Zero it up, so we've got Z, which is 0 at the top of the foam. X is going to, X0 is there and Y0 is there, so the part's going to cut in there. So once that's somewhere about right, start the machine up. Back over here. We've got to tell Mark III, the program, that X, Y and Z, where that router bit is now, is 0. So we zero out X, Y and Z, regen the toolpath, and then we hit the go button.
here's this piece, straight off the cutter. The shape.
Only about another dozen to go.
What number's that? Oh, we're nearly at the front.
Is it right?
What, number 2? There's 3. Okay,
That's why.
wrong one.
Much more better.
So what happens next?
Repeat about a dozen more times. Then glue it all together, smooth it down, glass it, and make a mould. Parting board and make a mould of it. Simple.